let's continue one section. I'm just going to share the document. So you can see here our discussion went on yesterday about ORM. About the ORM technology. I've given all the points like related to ORM technology. Like in Java application, data can be in objects. It's not data can be in objects. Data is in objects. And the technology that we know is JDBC, but directly this technology cannot able to send objects to the database or cannot get the objects from database. So it doesn't have that facility. So that's why I told that we are going for ORM. These are all the things I've explained in the last. Okay, you can read out next. Then we start our discussion with what is data JPA. We got to know about JPA. Then we discussed about what JPA defines. And from here I will continue. Okay, let's start our discussion from here onwards. Yeah. So coming to today's point. Yesterday, when we started our discussion understanding about Spring Data JPA. See. So now our requirement is we want to know or we want to discuss about Spring Data JPA and Spring Boot Data JPA. Okay. See. For example, if you talk about Spring Data JPA, in Spring Data JPA, first we need to define entity classes. Okay. I repeat once again, first you define the entity classes. So entity classes means it is a Java class which is mapped with a database table. The class which is mapped with a database table is called entity class. So the first step is writing the entity class. Then the second step is you should create one repository interface. I'm not talking about Spring Boot Data JPA. First, I'm talking about Spring Data JPA. You have to create entity class. Then you have to create repository interface. I'll tell you how the repository interface can be created. But you no need of writing the implementation class for this interface. As a programmer, you have to define only the interface. And for this interface, implementation class will be created at runtime by Spring only. So it's pretty new now because in core Java point of view, what we know is, okay, if you create an interface in the application, somewhere that interface must be implemented by creating a class. Otherwise, it becomes useless. Right? Just only creating interface doesn't give any functionality. Correct? Only creating interface does not give any functionality. First, process my statement in your brain. Okay. Only interface will not give any functionality. If that interface has an implementation, then only it can provide the functionality. What you can do with only creating interface? Write a program in core Java, only writing interface and execute it. In interface, what methods you have is abstract methods. What abstract method can do? Nothing. There is no functionality, right? Okay. So only with interface, application cannot get anything. No functionalities are obtained from interface. But if that interface has implementation, then application can get functionalities. Okay. So point is same. What's the point I'm talking about? In Spring Data JPA, you create a repository interface. Repository interface means it can be any name of your choice, but you have to create one interface. But its implementation class will be automatically created at the runtime by Spring, which means you write interface, Spring will write implementation class. In core Java, simply what? You write interface, but core Java doesn't write implementation class. You have to write implementation class somewhere. Only interface if you write, and don't say that Java will write implementation class for my interface. Java will not write like that. Okay, right? You have to write implementation for it somewhere. But whereas in Spring, what happens? You write interface, but implementation class will be created by Spring. That's the framework, the advantage of the framework. So if you are working with the Spring Data JPA to perform the database operations, okay, using Java objects. If you want to perform operations on Java objects, like CRUD operations on the Java objects on database, you no need of writing the implementation class in Spring. Spring only will define the implementation class at the runtime. But what you have to write is only interface you have to write. That is called repository interface. Interface name can be X, Y, Z, M, N, O, P. It is called repository interface. Don't feel that repository interface means interface name is repository, not like that. Repository interface meaning just it is an interface, right? It is an interface created with annotation @ repository on top of the interface. That will become what type of interface? Basically, repository interface. But don't feel that interface name is repository. It is not like that. Interface name can be X or Y. Doesn't matter. Interface name can be anything. Okay. Second, that should be very clear to every learner first. Apart from these two, third, you also need to define configurations. You define what? Configurations. JPA related configurations you need to define. Under this JPA related configurations, there are 4 configurations required. 4 bean configurations required. One is data source bean configuration. Second one is entity manager factory bean configuration. Third one is JPA vendor bean configuration. Last one is transaction manager bean configuration. These are all the different configurations that you need to write. Where if you are working with Spring Data JPA, it is Spring Data JPA. In Spring Data JPA, you have to define entity classes, you have to define the repository interface, and you have to define the configurations. Okay, so how do you write all these configurations in the Spring Data JPA? You write one configuration class, configuration class contains bean definitions. Bean definitions means what? You can write the bean methods with annotation called @bean. Now, how many @bean methods you have to write now? 4 @bean methods you have to write in the configuration class. @bean for data source, @bean for entity manager factory, @bean for JPA vendor, @bean for transaction manager. Like that, how many bean methods you have to create? 4 bean methods you have to create. For example, I'm not writing the complete, but first of all, how to define a configuration class in a Spring application? @configuration is annotation. Okay, now public class, let's say my config or something like that. Any my config is your class name. But in this class, you have to write the bean definitions by writing the annotation called what? @bean. For example, public data source return type, method name data source. You are writing some logic here. I'm not writing the logic, but some logic is there. Here some logic you are writing. Dot dot dot. Next again, @bean. Okay now, @bean. Public entity manager factory. Entity manager factory. Let's say entity manager is the name of the method, some name. Then some logic inside. Then again what? @bean, correct? @bean. Next word, public JPA vendor is return type. It should produce JPA vendor bean. JPA vendor. Some logic. Next one is what? Again @bean. Public transaction manager. Let's say transaction. So now I think you got to know what the configurations required. When you should define all these type of configurations if you are working with Spring Data JPA. Okay. And we know why Spring Boot framework got introduced. Okay. The main reason behind Spring Boot framework is configurations, auto configurations. In Spring Boot, Spring itself will handle almost all the configurations required for the project. Almost 0 configurations you have to define, or sometimes some less configurations maybe. But most of the configurations will be handled by Spring only in Spring Boot framework. But in traditional Spring framework, in the traditional Spring framework, what? All the configurations must be defined by programmer. Okay. We are discussing about what? Spring Data JPA. So in Spring Data JPA, if you want to work with JPA to perform the database operations on Java objects, like a CRUD operations on the Java objects, what are the things that you have to understand is, you should write one entity class or one or more entity classes. How many classes, entity classes you need, you have to define them. Right. Next, you should create what? Repository interface. Then you have to write configurations. Define all the configurations. Am I done not? And not only these 3, 4th point is there. What the 4th point is? You have to add multiple dependencies to the pom.xml file. Add multiple dependencies. You have to add Spring ORM dependency, MySQL driver dependency, Spring transaction dependency, JPA vendor dependency, multiple dependencies we need to add. Because you are in Spring now, right? In Spring, you don't have any starters. Starters are available in Spring Boot, but not in Spring. In traditional Spring framework, you don't have a single starter. You have to add what? Add multiple dependencies to form.xml. You have to configure multiple dependencies in form.xml. So these are the 4 things that you need to do. The 4th one, better I will add the 4th one also. What's the 4th one? Next, number 4. Add dependencies, multiple dependencies in form.xml. Add means configure. Configure multiple dependencies in form.xml. Now tell me, these are all what we need to do in Spring Data JPA. Okay. But we got a Spring Boot framework now, and we are not directly working with the traditional Spring framework now, right? In traditional Spring framework, you have tried entity classes, then you have tried repository interfaces, then some configurations, bean definitions, and then multiple dependencies you need to configure in form.xml with proper versions. Proper versions means with the compatible versions. It's not like Spring Boot, right? In Spring, you need to handle. Suppose if one dependency you added high version and one dependency you have added with a low version, you will get a version incompatibility issues. Because of version incompatibility, you will get exceptions. You will get what? Sometimes a minor version also is going to be very important. Minor version means, for example, you are adding 7.0.3, 6.9.1. That minor version also sometimes makes exception. That minor version incompatibility also will make exceptions at runtime. So you have to add multiple dependencies in form.xml with the compatible versions. This is Spring Data JPA. But our requirement is we are not learning Spring framework here. We want to work with Spring Boot framework, not with the Spring framework. Got it? We want to work with the Spring Boot framework, but we do not want to work with the Spring framework. What will happen in Spring Boot then? In Spring Boot, all these configurations will be automatically done by Spring Boot. Right, okay? In Spring Boot, you no need of writing these configurations. You have to write entity classes. That's for sure. Okay. So I'm not saying that in Spring Boot you no need of writing any entity class or any repository interface. Means what Spring Boot can do is nothing. Okay. Spring Boot is like Spring framework only, but only what is the advantage of Spring Boot is you no need to take care of adding many dependencies, their versions and configurations. Spring Boot has given new type of dependencies and they are named as starter dependencies. They are named as what? Starter. Yeah. You no need to add multiple dependencies. Instead of multiple dependencies, you just add one starter dependency in the form.xml file. It's a simplified version. Okay. One starter means it is internally a group of dependencies, jars, multiple dependencies with respect to versions, with proper versions. Okay, so Spring Boot has given starter bundles. One starter means one bundle. If you open that bundle, inside that you can see multiple Spring dependencies with respect to versions. That is starter. Good. Come to Spring Boot Data JPA. Right now, our discussion went on with what? Spring Data JPA. Whether you are working with the Spring Data JPA or Spring Boot Data JPA, but entity classes we need to define. Because entity class used to map this Java class with a database table. You have to map them. Mapping is required. Between what and what mapping is required? Java class and database table mapping is required. If you map them, then this JPA will store the objects of this Java class into the table. Otherwise, how it knows? Suppose you have a Java class. In the database, 100 tables are there. How does this JPA know in which table have to store this object? Table 1 or table 2 or table 100? You don't know. For that, what is required for this JPA? Mapping is required. You have to map. If you map the class with a table, then only JPA can send object of this class to that table, or will load the object from the table. You got my point, right? Otherwise, what your application contains? Hundreds of classes. Your database contains hundreds of tables. You don't know in which table, which class object I need to put, or from which table I need to get. Who don't know about this? JPA. JPA. Are you able to get my point, right? So definitely mapping is required. What is required? Mapping. Mapping is required. Are you able to get my point, right? Nice. That mapping is required. Right, okay. Like, for example, based on hall ticket numbers in exam centers, what happens? Rooms are allotted. From this hall ticket number to this hall ticket number, these students should sit in this hall number 1. That's a mapping. That is called what? Mapping. If no mapping is given in that, if no mapping or no board is given or no board is placed in front of the exam center, then right, okay, the student don't know where to sit, in which classroom or in which hall number I need to sit to write the exam. He don't know anything. Correct? That is called entity class. Coming to Spring Boot Data JPA. Entity classes we need to define. Repository interface also we need to define. Entity classes, repository interfaces we need to create. Means a DAO interfaces we call them. DAO means what? A data access object. It's one design pattern which purely contains the data access functionality. We are not going to mix up it with the business logics. We are defining them separately. They are called DAOs. DAO stands for data access objects. Okay. So what are the two things that are mandatory? Entity classes and repository interfaces we have to write even in Spring Boot also. But you no need to write configurations. Who will take care of writing these configurations? Spring Boot will handle it. Spring Boot will happily do all the configurations necessary. You no need to bother about configurations part. All these 4 configurations will be taken care by Spring Boot only. That's the first point. Number 1. Number 2, you no need to add multiple dependencies in form.xml. Instead of that, you need to add only a single starter dependency of the Spring Boot in form.xml file. That's it. Now you got the difference between what and what? Spring Data JPA versus Spring Boot Data JPA. And we need to work with the Spring Boot, not with the Spring Framework. Working with the Spring Framework is a bit complex than working with Spring Boot. Okay, right. So today we will talk how to write the entity classes. Next, how to define the repository interface. How can I create a repository interface? These 2 things. I no need to explain how to add the starter in the form.xml, that you know. Okay, you know already, right? Are you manually writing dependency tag in the form.xml? No, you are generating the project. You are selecting their data JPA. Then automatically what happens? Spring Boot starter data JPA dependency included. So I no need to show anything about that. But I need to show about what? Entity class and repository interface. These 2 things we will concentrate in today's class. So first let me write it. Spring Data JPA. point is Spring Boot data JPA. Tell me, what will happen in Spring Boot data JPA that we want to write? Tell me, what will happen in Spring Boot data JPA? In Spring Boot data JPA. In Spring Boot data JPA. What to do in Spring Boot data JPA? We need to define what and what? Entity, classes, second, repository interfaces. Entity classes and repository interfaces. And what about the rest of the work? That's it. The Spring Boot will handle the required configurations, or will do otherwise. Will do the required configurations. Spring Boot will do the required configurations automatically, or will complete the required configurations automatically. Spring Boot will complete the required configurations automatically. Am I clear with this point? Spring Boot will complete the required configurations automatically. Apart from that, right? The Spring Boot starter. Which starter? The Spring Boot starter to be configured in form.xml or required in form.xml is Spring Boot starter data JPA. What's the name? Spring Boot starter data JPA. That's it. Of course, this one also you are not manually doing this, but you have to know. So in Spring Boot only what and what are enough now? You write the entity classes and you write the repository interfaces, and that's it. And who will take care of remaining configurations required? Spring Boot will handle. So first we need to start learning what today? How to write entity class. How to write entity class. Next, how to create repository interfaces. I am going to explain these two. Okay. Let us keep in our document. Okay, now let us keep in our document. So straight away we are going to discuss how to write entity class. Let me. Then now question is how to write entity class. Sure. Okay. Now what is our question? Now our question is all about how to write entity class. That's what our question. Sure. I will explain about how to write entity class. First of all, what is an entity class? Entity class is nothing but a Java class. It is mapped with a database table. That is called entity class. Entity class is nothing but it is a Java class which is mapped to a database table. Yeah, that is called entity class. Now I am talking about entity class. Who is this entity class? It is a Java class which is mapped to a database table. A table in the database or a database table, anything which is mapped to a table in database or mapped to a database table. Now this is called what type of class? Entity class. Okay, entity class. Okay. Question. Why should we map? What's the question? Why should we map the Java class with a database table? Got it right? Why should we map? Why should we map? What's the answer for this? Why should we map Java class with a database table? Application contains many Java classes and a database contains many tables. So JPA don't know, okay, which class objects to be persisted into which table in the database. Persisted means stored. Okay, right? Which class objects to be persisted to which table in the database. Who don't know about that? JPA. That's why we need mapping. Folks in online, try to get this point. In application or in our application, in our Java application, we can have multiple classes like customer, employee, order, product, delivery, etc. Payment. In our Java application, we can have multiple Java classes like customer, employee, order, product, delivery, etc. And in a database, there can be multiple tables, and in database there can be multiple tables. So JPA don't know which Java class object needs to be persisted to which table in the database. Who don't know about all these things? JPA. So it's a big answer. It is a big answer, right? See the answer here. Okay. Which Java class object needs to be persisted to which table in a database? Which table in the database? It doesn't know about that. That's why what we need to define? We should map a Java class with a what? That's why we should map the Java class. We should map a Java class with a database table. A Java class with a database table. So his answer is clear now. Now next point. Why should we map is okay, answer correct. But how should we map? Why is okay, done. You got the answer, solution, right? Very good. Your application contains many classes. Your database tables are database contains many tables. By default, JPA don't know which class object to be stored in which database table. You don't know about that. So that's why you are defining mapping. How to define that mapping? For that, JPA has given some annotations. We have to use what annotations? JPA provided standard annotations. Okay. Now next question comes in. I mean, I'm just writing like a point. What's my next point I'm writing? Then how to map. Then how to map. Okay, then how to map then? Then how to map? What is the answer for this? Annotations. JPA has provided standard annotations to do this mapping. JPA spec or specification better. JPA specification has provided standard annotations like @entity. What is it? @entity, @table, @ID, @column, etc. Many are there, I'll explain, but basic annotations are 4. @entity, @table, @ID, @column, etc. to define the mappings. You got the mappings now? Very good. Now coming to first keeping this into one topic. Folks in online, let me know if you have any queries in the chat box. Okay, so that I'll try to answer them for your clarity. So we got to know entity class, and we are good with this. Okay, we are good with this. Now let's move on. Okay, right? Now what are the annotations given? Entity, table, ID, column. These are the annotations you have to use to define the mappings. So now this is clear. What is the next step? We should start understanding about these entity, table, ID, and column. First one is what? Entity. Entity annotation just marks that this class is a entity class. If it is marked as entity class, then only its object can be persisted to the database or can be loaded from database. You can store it in database or you can load it from database if that class is marked as what type of class? Entity class. And how to mark it as entity class? Just @entity on top of the class. If you're at @entity on top of the class, then what? It is going to become like entity class. Okay. At a table, what is the use of this annotation? To specify the name of the table in database. These two, entity and table, both these annotations are class level annotations. What level? Class level. They are class level annotations. What and what are class level annotations? Entity and table. Next one, ID and column, the remaining two. These two annotations are field level or method level annotations. Field level or method level means we can use them at field level or we can use them at method level. Okay. And at ID indicates that this field is a primary key field in the entity class. It is a primary key field of this entity. Primary key field means what? This field is mapped to the primary key column in the table. What column? Primary key column in the table. Primary key column on that in the table. Okay, right. Understand the point clearly. Okay, right? At a column is to specify the name of the column to which this field should be mapped. Okay, specify the name of the column to which the field is mapped. That is @column. So 4 annotations are very common annotations to define entity class. There are plenty of other annotations will come later. We are only just writing the first example. We are trying to start our first example. And to start with the first example, you should know these 4 annotations. What are the 4 annotations? Entity, table, ID, column. In that, entity and table both are class level. ID and column both are field level. Field level. These are the 4 annotations. Right? At the rate ID represents that this field is a primary key field. What field? Primary key field of this entity. Always primary key field of the entity is mapped to primary key column in the table. Which annotation that we need to write to map it with a column in the table by using at column? What is that? At column. At ID, at column. Both are field level or method level annotations. But first two are class level annotations. Let's see how it can be done. Let's see the example. Okay, now I'm writing the example. For example, you see the for example. Now this is just example. This is database. This is our database. Right. This is database. This is database. In the database, we have a table. Consider it is a database. Right, it's a database. It's a database. Okay. In database, we have a table. In database, we have a table. We have a table in the database. Database has a table. In database, I have a table. For example, the table name is traditional table EMP. EMP is my table. And this table has columns. The columns in the table okay, let's say for example, the columns in the table EMP and O. E name, sal. Okay. Take 3 columns. Later we can say many columns, but right now it is 3 columns. Now what are the 3 columns in my table? EMP and O, E name, sal. What are these 3? These are the 3 columns in my table. Database table. My table has 3 columns called EMP and O, E name and sal. Now in my application, I have a Java class. Now this is my application. In application, I have a Java class. Now this is my application. This is my Java application. Within my Java application, I have a Java class. In my Java application, okay, I have one Java class. This is my employee class. Let me write the employee class. Public class employee. and we start writing fields of employee. Private, integer, EMPNO. Private, string, ename. Private, double sal with respect to setters and getters. Getters and setters. This is what my Java class. Am I clear with now? Now what is my requirement now? I have to map it with my database table. Now this is my Java class, but now I need to map it with the database table, right? How to map? Annotations are provided. First of all, how to mark that this class is an entity class at entity? Where should I write this annotation? At a class level. At a class level. Okay, let me use a different color. At entity. Now it is telling that what this Java class is an entity class. Entity class means what? It is mapped to a table. So which table you want to map this entity class with? The table EMP. So annotation at a table, name equal to EMP. Very easy to write. At a table, name equal to EMP. Now it is mapped to which table in the database now? EMP table in the database. Next. This is my class in application. Now start writing. Tell me. EMPNO is a field. To which column you want to map it with? EMPNO. If a field is mapped to primary key column of a table, then this field is called an ID field. How to declare that it's an ID field? At ID. What's the annotation I'm using? At ID. At ID. To which column you are mapping it with? EMPNO. At column. Name of the column is what? EMP. This column annotation to is to specify name of the column to which the field is mapped. Okay, right? The column name to which the field is mapped. If the column name also same as the field name, column name also same as the field name, then no need to write column annotation. If you look at this here, what's the column name? EMPNO. Field name also what? EMPNO. If the column name is the same as the field name, then there is no need to specify column annotation to map this field with a column. But here it is optional. I can remove this, but still my code will run because names are same. Next one, ename. Ename is not a primary key field. Ename is going to map with the ename column. Ename column is not a primary key. That's why we don't write ID. And we should not repeat ID annotation for more than once. We should not repeat the ID annotation for more than once in the entity class. We can make how many fields as ID? One single field only as ID. Yes. At column. At column. What's the column name? Ename. You can write in lowercase or uppercase. Just for clarity, I'm writing in uppercase. You don't feel that I must define the column and table name in annotation in uppercase only. No naming convention like that. Column name must be in uppercase only. It's not like that. You can write in lowercase or you can write in uppercase. As you know that the column names, table names are case insensitive. Yes, they are not like Java, right? Select star from EMP, select EMPNO, comma, ename, comma, sal, comma, EMP, like that. From EMP, you are writing some query, right? When you're typing that query, you write in uppercase letters, the query will run. You write in lowercase letter, again the query will run. No difference, right? You don't find a difference between the uppercase query and lowercase query, both will run. It is not case sensitive because SQL is not case sensitive. HTML also not a case sensitive. What and what are not case sensitive? HTML and SQL are not case sensitive, but Java is a case sensitive. You should not write string in S lowercase, system in S lowercase. Can you write like that? Public static void main M in uppercase. Can you write like that? No. Okay. Next one, column. At column. At column. Name equal to. So now this is called which class now? Java class. Now this Java class is mapped with whom? Table. It is mapped to a table in the database. It's mapped to a table in the database. You can define the getters, setters, whatever, constructors, whatever you want, you can define. Define the constructors, define the setters, and define the getters. So whatever is required, you can define here. But basically, this is called one entity class. It is mapped to a table in the database. Okay. To map like that, what are the annotations we have used? At entity, at a table, at ID, at a column. This is called what type of class? Entity class. These are basic annotations. Furthermore, lot of annotations are there in JPA. Plenty of annotations are there in JPA. We will discuss some group of annotations in one example like that. Okay, right now basic annotations are what? Entity, table, ID, column. Writing column is optional. Why writing at column annotation is optional in this case? Because the names are same. Here, what's the column name? EMPNO. What's the field name? EMPNO. Both are same. That's why writing this column is optional. Here also, writing this column is optional. Writing this annotation is optional. But what is mandatory? ID is mandatory. Okay, I can remove the remaining. In coding, I'll do like that. But right now, just remember that writing at column is optional. When it is mandatory, when should I specify the column name to which the field is mapped? If the names are mismatching. If the field name is mismatching with the column name, then we need to write annotation, at column annotation. Nice, nice. Now this is my Java application. In my Java application, this is my entity class. It is my entity class. Okay. I'll keep this arrows. The arrows are saying that. Okay, right. This is table. Okay, table. Even table annotation is the same thing only. But here I can't avoid this table annotation, right? I cannot avoid the table annotation here. Why can't I avoid the table annotation? Okay, what is the name of the table here? EMP is the name of the table. EMP is name of the table. Right? What is the name of the class here? Employee is the name of the class. Employee is the name of the class. Tell me now, this name of the class and name of the table, are they same or different? They are different. They are different. If they are different, then we must add annotation. Which annotation we must add? Table. This annotation we must add. Table name is mandatory here. Table name is mandatory. If, for example, table name also employee. For example, table name is also what? Employee. Class name is also what? Employee. Table name is the same as class name. Means what? The class name and table name both are matching. Then writing this annotation is optional. Which annotation is optional? At a table, we can avoid this. We can avoid this. So hope I'm clear with this. Now I just want to go to keep this arrows. Now tell me, this class employee is mapped with which table? EMP. It is mapped to EMP table. Am I clear with that? Mapped to which table? EMP. Table name EMP. These two are mapped. This class is mapped to EMP table. Next, this EMPNO is mapped to EMPNO. Next, this ename is mapped to this ename column. This is sal field is mapped to this sal column. This is called mapping. Am I clear with the mapping now? Right. Let me keep this. So hope I'm clear with this. Just a minute. So we got entity class concept, basic concept of entity class. We got the basic concept of which class now? Entity class. We got the basic concept of entity class. We got the basic concept of entity class. Okay, sure. What are class orientations? Entity and a table. Okay, right? Now you know the mappings, and if the table name, okay, if the table name and the class name are matching, then writing table is optional. Similarly, if the column name and field name both are matching, then it is no need to map the field with column, because column name is also same as field name. If the field name matches to column name, then no need to map to a column by using annotation called what? Column. They are optional, just like note. Just like a note. Tell me, at entity and at a table are which annotations? Are the class level annotations. At ID and at column are field or method level annotations. Means what these annotations you can write on methods also. Which methods? Setter, getter methods are there. Now you can write on top of them. You can write on top of the setter method or getter method. You can write the annotation. Able to follow me now? Right. But mostly we write on fields only. Okay. At ID at column are field or method level annotations. Next point. If the Java class name is same as table name, then at a table is optional. Who is optional? A table is optional. When? If the Java class name is same as table name. Next one. If what? The field name. If the field name is the same as column name, then at a column is optional. So am I clear with? So for what are the statements we got it? This is called writing what class? Entity class. We are done with basic way of writing the entity class. So which annotation is mandatory on top of entity class? At entity. At entity is indicating that what this Java class is an entity class. Okay. Entity class must contain ID. Remember that. Okay. Entity class must contain what? ID. What at ID indicates? At ID indicates that this field is a primary key field which is mapped to a primary key column in the table. Okay, to represent that this field is mapped to primary key column in the table, which annotation we use at the ID. Okay, so far about entity class, at least we got some idea. The 4 basic annotations we know, but plenty of annotations are there. I'll explain. In further one example, I will explain. Okay. We are done. About entity class, we know. What's the next one? Repository interface. Now, what's the next question? How to create a repository interface? What's our next question? How to create repository interface? So hope so far am I clear with all of you? Is the concept is clear so far? Right? Okay. Right. What is the difference between Spring Data JPA and Spring Boot Data JPA? If there's a question asking, okay, in an interview, then what answer you have to say? In Spring Data JPA, we should define entity classes. We should define repository interfaces. We also need to define the configurations like data source bean, entity manager factory, JPA vendor, and a transaction manager. Along with that, we also need to add multiple dependencies with the compatible versions in the form.xml file in Spring Data JPA. But in Spring Boot Data JPA, we have to only define the entity classes and the repository interfaces, but the rest of the configurations part will be handled by Spring Boot only by default automatically. And we need to just add one starter dependency in the form.xml. What is the starter? Spring Boot starter data JPA. Spring Boot starter data JPA. That is a dependency that I need to add in the form.xml file. That's how Spring Boot is simplifying the application development. Am I clear with that? No. Next. How to create a repository interface. Now, to create a repository interface, you have to understand now. There is a hierarchy. Okay. While creating repository interface, multiple options are there. Number 1, our interface has to extend CRUD repository interface. Who is that? CRUD. CRUD, C-R-U-D, CRUD repository. Or number 2, our interface has to extend staging and sorting repository interface. Second option. 3, our interface has to extend JPA repository interface. So how to get a repository interface means 3 options are there. Option 1, our interface has to extend CRUD repository. So what is the, how to get repository interface now? Number 1, by extending CRUD repository. Number 2, by extending staging and sorting repository. Number 3, by extending JPA repository. In how many ways we can create that? 3 ways. Then, let me explain again. Tell me first of all what are the 3 ways now? Number 1, number 2, number 3. What's the number 1? CRUD repository interface. Number 1 is what? CRUD repository interface. Number 1, CRUD repository interface. Okay, number 1 is by using what? CRUD repository interface. CRUD repository interface contains two type parameters. First one is T, ID. T, ID. I'll tell you what is T, what is ID. T, ID. Number two, paging and sorting. Paging and sorting repository interface. Number three, JPA repository interface. Guys, in how many ways repository interface can be created now? 3 ways. One is what? CRUD repository interface. Second one is what? Paging and sorting repository interface. Third one is what? JPA repository interface. Like that, in how many ways it is there? 3 ways are there. 3 ways are there. 3 ways are there. Very good. Come to the point. So how do I know whether I should extend this one or this one or this one? Okay. With interface, if you want to perform only CRUD operations on the database, okay, from your repository layer, only what operations you want to perform? CRUD operations you want to perform. CRUD operations you want to perform. CRUD operations if you want to perform. CRUD operations means only insertions, updations, deletions, and retrievals of objects. Only CRUD operations you want to perform. Then extend what? CRUD repository. You want to perform only paging and sorting operations. Paging means pagination. Paging means pagination. Pagination. You want to perform only pagination and sorting operations. Then you extend your repository interface from paging and sorting repository. Extend that paging and sorting repository. I'll tell you what is pagination. Then the doubt comes here, what is pagination? Sorting means I know. Ascending order, descending order. Sorting I know. But pagination means, what is pagination? Anybody have an idea? That's it. Pagination. Example. We all have Gmail accounts. Our inbox is containing thousands of emails. Hundreds of emails or thousands of emails. And we are unnecessarily maintaining so many email accounts. If you have any such type of unnecessary email accounts are there, you first drop them, close them. Because they are eating more water. They have to maintain the data, right? Big data centers they will maintain. Google is maintaining big data centers, right? Because of our selfies, because of our unnecessary emails, right? Okay. Lot of natural calamities happening. Heat is getting produced from big data centers. They cool down them. ACs are not enough. They are using some gallons of water to maintain their data centers safe without crash. Okay. So whenever you have unnecessary emails, spam emails, for example, your Uber trip is completed. Even I also have many. I also need to delete. Some of them I've deleted. Because without doing that, if I tell you that is wrong, I'll also do. But still I have many. When you complete some Uber trip, you are getting one email, Uber receipt. But trip is completed, you paid the money, everything is okay. You got the email, right? Do you want to still maintain that email? What's the use of that? Right? Immediately delete that. Every weekly, one bank alert message is coming for your email about your so amount is there currently in there. Once it is done, delete it. Like that, if everybody do like that, we can save gallons of water. Okay, right? Data centers has to maintain all these things, right? Okay, That's why unnecessary email accounts. Some people just for fun creates accounts. Just for the fun. When they don't have any time, any work, when they're sitting idle, simply creates one new email account with the different names. Some people have that habit. Because once upon a time means not very far also, very near. For example, you go down for 10 years back or 5-6 years back at least, before Corona. Children doesn't have their own email accounts. Children doesn't have their own email accounts, right? Only adults have email accounts. But now, children have their own email accounts more than adults. Because they have to play the games. For that, he'll ask email, enter your email ID. They are not telling the parent, my son has created many email accounts like that. To play the game like Roblox, some ninja game, something is there. I don't know, he plays many games. Okay, he don't listen to me actually. So, the point is now, he created his own email account. He created email account, he created many WhatsApp groups. Their friends, they will chat in WhatsApp group about the game. Log in this time. Okay, right. Different names. For example, I can show you now. Yesterday night also I created one WhatsApp group in my mobile only. The Buddies Forever or something like that. WhatsApp group name. Okay, right. So it has to maintain lot of space. They have to maintain very big data centers because we are polluting by putting so many pictures, selfies. Right? Okay, pictures will have a lot of memory, right? And all those are going to be in your Gmail account only. Right? Okay, when you are configured one Gmail account in your mobile. So whatever photos that you are seeing, whatever photos that you are taking, selfies and all, they're all going into that, right? So lot of resources are getting wasted. So that's why, if by chance, if any unnecessary things are there, better to drop out them. Simply delete them so that we can save many things. Come to the point. There is something called CRUD repository. We are here. Now question comes here, paging and sorting repository. What is paging? That's where our discussion went on. Pagination. So we all have Gmail account. Our inbox is containing many emails. But are you going to see all the emails at once? No. For example, by default, it's going to show us the latest 50 emails whenever you log in, right? 50. If you want to look at 51 to 100 emails, the emails that came before this, after this, then the emails which are came, these are the latest ones. Some emails came before this date, right? So how do you see them? You have navigation. There is a button there, next button, something like that. Then what happens when you click on that? Next page of emails will come. Your inbox is containing thousands of emails, but at a time it is not showing the all data, right? The data is now divided into chunks. Chunks of data. Okay, what is the chunk size here? 50. One more next chunk size 50. Again next chunk size 50. This is called chunks of data. The data, when you have a large amount of data, divide it into chunks and display each chunk separately, page by page. This concept is called what? Pagination. So your Gmail inbox is best example for what? Pagination. And e-commerce platform. So all those no, you are in some 100 products. At the bottom you are getting next button. When you click on the next button, then the page of products. This is called pagination. Now you got meaning of what is pagination? Right. So everywhere we are using pagination. Your Gmail has pagination, your Amazon has pagination, and everywhere we have pagination for sure. Mostly. So if you want only that kind of pagination and sorting operations only, then you have to extend what? Paging and sorting repository. JPA repository. You want CRUD operations, you want paging and sorting operations also. You want what and what? CRUD operations. You also want what? Paging and sorting operations also. Along with that, some other JPA specific operations also you want. I'll tell you what are those other. Then you have to extend what? JPA repository, because JPA repository interface extends CRUD repository and also extends paging and sorting repository. Extends what and what? Paging and sorting repository. For the hierarchy now, JPA repository is a child of CRUD repository and paging and sorting repository. And this CRUD and paging sorting repository both came from one parent interface called repository. But it is a marker interface. It does not have any abstract empty interface. Both these interfaces came from one more parent. What's the name of the parent? Repository. Repository. That's a parent repository. So am I clear with the point now? Yes. So tell me how many ways we can able to create now? 3 ways. 3 ways. Just a minute. First, how to create a repository interface. I'll show you the diagram. Instead of drawing it again, since we don't have much time to draw it now, I'll be copying it to show you the diagram. And I'll also show you the statements. You can see here. Okay, there is an interface called what? Repository. It's an interface. Okay, what are the childs of this repository? CRUD repository. Next one, paging and sorting repository. And what is the last one? JPA. JPA repository extends what and what? CRUD repository and paging and sorting repository. Will you get any diamond problem here? No. It's not a diamond problem because they are interfaces, they are not classes. If they are classes, it's a diamond problem. Because Java does not support multiple inheritance at classes level. One class cannot extend multiple parent classes, but one interface can extend multiple parent interfaces. Who are the parent interfaces here? CRUD repository. Next one, paging and sorting repository. It's okay. Interfaces is okay. These are diagram I want to show. In that, these two came from where? Repository, and it is a marker interface. It is an empty interface. And this CRUD repository has provided some methods. This paging and sorting repository has provided some methods, and both the methods are inherited to JPA repository plus added some new methods. Now that list is here, but I'll talk about the list in detail tomorrow. But you can see some methods here. CRUD repository methods. Save the entity, find by ID, find all, delete by ID, delete all, exists by ID. What are these 7 methods to perform what operation? Save means it can do 2 things. It will save the given entity. If entity already exists, it will update it. Means this one method can perform 2 things: insertion, updation. These 2 methods will perform retrieval, R. C means creation, R means retrieval, U for updation. This one method can do C and U means what? Create and update. Create means insert, and update. These two methods will perform. Retrieval. These methods will perform. Deletion. Now tell me finally all these methods will perform. CRUD operations. Got my point? In that find by ID retrieves only one entity by ID. ID means primary key. How many entities can be there with the primary key? One. Find all means all entities. Like a select star from EMP. Equal to what? Select star from EMP. All records. Delete by ID. Deletes with a given ID, one entity. Even deletes the given entity by calling delete of entity. We can pass only ID or we can pass entity. Delete all means all entities are deleted. Like a delete from table. Now these are which methods? CRUD operation methods. So this is what actually I'm trying to explain how to define a repository interface. Okay. For today, I will add only the statements up to this. Tomorrow, I will give you more on this. This is what I'm saying. Okay, right? Good. Now tell me what are the different ways that you have to create your repository? One is CRUD repository. Next one, paging sorting repository. Or next one, JPA repository. Only CRUD operations you want to perform. Then extend what? CRUD repository. You want pagination and sorting operations. Extend what? Paging and sorting repository. And you want both CRUD paging operations plus additional JPA operations, and go for JPA repository. So totally, in how many ways I can create a repository interface? 3 ways. Will be discussed in more detail in tomorrow's class. Okay? Thank you. Let's meet on tomorrow. Focus in online. That's the session for today, and let's meet tomorrow to discuss more in detail. And we will start writing the first application tomorrow.
Recording stopped.
చెప్పనా నువ్వు చేయకపోయావు అది